Hello guys, so today we'll find the solution of a question of differential equations. We'll solve this by the integrating factor method of solving differential equations. It is a fairly simple question and let's get straight into it. So for the question we have, it's a word problem. So we have a room containing 20,000 cubic feet of air. 600 cubic feet of fresh air flows in per minute. So the inflow rate is 600 cubic feet per minute, and the mixture is exhausted at a rate of 600 cubic feet per minute. So the outflow rate is also 600. When is the amount of fresh air yt at any time t? What is the amount of fresh air yt at any time t if y0 equals to 0? After what time will 90% of air be fresh? So we have two parts kind of to this question. First is finding the differential equation of yt at t, and also we have to find the time after which 90% of air will be fresh. So first let's start with finding this equation. So we have that the yt is the amount of air which is the amount of air which is fresh at time t. So the rate of change of fresh air will be dy by dt, or y dash equals to rate of in fresh air inflow minus the mixed air outflow. So this is the basic formula for setting up the differential equation, and from this formula we get that y dash equals to 600 minus 600 by 20,000 y. So here it's just that fresh air inflow is 600 and the outflow will be 600 by total air in the room, that is 20,000 into y, which is the amount of fresh air in the room. So this is the basic differential equation. We'll simplify this and get y dash equals to 0.03 y equals to 600. So this is the differential equation which we have to solve for finding the solution of y, and we'll solve this by using integrating factor. So our integrating factor would be integration 0.3 dt, because y is dependent on t, so it would be 0.03 t. So the integrating factor is 0.03 t as y is a function of t, and now we'll just put yt equals to, now we have e raised to power minus h c plus, so our we have 600 as this term, so it would be 600 integration so our integration would be e raised to power h dt. So this is the solution of the equation. Now we just need to solve it. First we'll put the value of h, which is 0.03 t. Now integration of e raised to power st is e raised to power st by s. So we have e raised to power minus 0.03 t c plus, c is the factor of integration here. I forgot to tell you before. So c is the constant of integration. So 600 by s in this case is 0.03 e raised to power 0.03 t. So this value comes out to be 20,000, and we have c e raised to power minus 0.03 t plus 20,000 e 0.03t minus 0.03t, which is 0, and therefore this becomes e raised to power 0, which is 1. So we have y of t equals to ce minus 0.03t plus 20,000. So this is our equation, but c is unknown here. So for finding c, we are given that y at 0 equals to 0. So we'll just put it y0 equals to c e raised to power c e raised to power minus 0 plus 20,000, and which is 0, and therefore we get c equals to minus 20,000. So we solved for c by having the initial value problem that y0 equals to 0. So now the equation is 20,000 minus 20,000 e raised to power minus 0.3t. So this is the required equation, and this equation represents the amount of fresh air at any time t, and we can see that this is dependent on time, so y is therefore dependent on t. And now we have to solve for this and find the amount of time required after which 90% of air would be fresh. So 90% of fresh air means 90% of total room size is 20,000, so it would be 90% of 20,000, so it is 18,000. So for finding this, our y would be 18,000, and 20,000 minus 20,000 e raised to power minus 0.3t. So here we get that 2,000 equals to 20,000 e raised to power minus 0.03t. This implies that e raised to power minus 0.03t equals to 0.1. Therefore, by solving this equation using logarithms, we get t equals to 77 minutes. So after 77 minutes, the 90% of air will be fresh in the room. So this is how we solved this question. I'll repeat how we did it. So we took that yt is the amount of air which is fresh at time t, and so the dy by dt, the rate of change of fresh air, would be rate of fresh air inflow minus the mixed air outflow. And then we got this equation, which we solved by using the integrating factor method, and got the final equation to be this. But we had the initial value problem that y of 0 equals to 0. We put that and found c, and then we got this, and then we 90, then for finding the amount of time required for 90% of air to be fresh, we just put in the value of y as 18,000, which is 90% of 20,000, and we got out that time taken would be 77 minutes. So this was the question, and we have the solution for it. If you want to go through it again, you can pause the video and go through it again. Hope you guys understood it, and thank you for watching.